Okay, so now we're going to come on to question 2 of the PED worksheet and the mathematical part of it, of course. And it says the following table illustrates the demand conditions faced by another monopolist. Okay, so don't worry about that yet. That'll make more sense later on. And it says calculate the price elasticity of demand when price falls from 10 to 8. Okay, so at a price of 10, right, that's P1, that's the first one, quantity demanded is 12. That's where I'm getting this from. At a price of 8, quantity demanded is 24. Now, just to be clear, the absolute formula for PED is the percentage change in quantity demanded over the percentage change in price. Now, let's just think about this for a second, right? If quantity demanded goes from 12 to 24, that's 100%, okay? Change. It's a 100% increase. It doubled, right? If price goes from 10 to 8, that's a 20% fall. Okay, so your answer is actually -5. What that means in terms of PED is that if price rises by 1%, quantity demanded will fall by 5%. This number, this answer to PED represents the percentage change in quantity demanded following a 1% change in price. It's averaged out in the formula, essentially. Now, what if you don't get nice numbers and you can't work that out? Well, then we use this formula. And this is literally that, just a simplified version of that, okay? That's all it is. So let's have a look here. So the first thing is, and I know it may seem intimidating because you've got a fraction over a fraction, but we've got Q2, which is 24, minus Q1, which is 12. So there's Q2, 24, Q1, 12, all over 12, okay? And that's divided by P2, which is 8, minus P1, which is 10. I'll talk about this minus figure in a second. And all of that's over P1, which is 10. Now, let's just simplify this. 24 minus 12 is 12 over 12, okay? Divided by minus 2 over 10. Now, what certain people do is, and there's nothing technically wrong with this, but what certain people do is they simplify this, so that'll simplify to 1, and that'll simplify to minus 0.2. But what I like to do is just, I suppose from my days in primary school, okay, you can go, I'll cancel these down, that's fine, okay, equals, let's say 1 over 1. Now, how do you divide this fraction by that? Well, and I'll simplify this, which is minus 1 over 5, okay? Well, what you do is you flip this one over and you multiply. So it's multiplied, instead of 1 by 5, it's 5 over minus 1. 1 times 5, how do you multiply fractions? Top by top, bottom by bottom. And 1 times minus 1 is minus 1, and that equals minus 5. Okay, so all I'm doing there is just showing you how to do these. Use this formula. Take your time, write them out like I've written them out here, and surely, you should be absolutely sorted, okay? Now, that's that question done. So a nice, simple, and forgive me while I move the camera again, a nice, simple intro into PED. Now, here we are in Ruritania. The demand for butter is given by 420 minus 19p, right? And then what we're saying is where QD is quantity demanded of butter per year in millions of kilograms, remember that, and prices in dollars per kilogram. Calculate the quantity of butter demanded per year when the price is $7, right? So all we have to do here is go QD equals 420 minus 19p. QD equals 420 minus 19 times 7. QD equals 420, and this is where I get out my trusty calculator, okay, and I go, I just want to move this so you can see it, okay, 19 by 7, okay, 133, minus 133, QD equals, I'm going to go 420 minus 133, and that equals 287 million kilograms, okay, that's the quantity at that price. Right? Now, calculate the quantity of butter demanded per year when the price per kilogram is 10. All right, well, we know how to do this. We're calculating quantity demanded. We're told that quantity demanded equals 420 minus 19p. We know, because we're told in the question, that price equals 10. So instead of p, we go 10. QD equals 420 minus 190, and then QD equals 230. Okay, million kilograms. Right? No problem there. And so again, we're just working our way through it and reminding ourselves what we know and why we should be confident. Now this again is the formula. So P1 was 7, and then at a price of 7, we already worked out in this question up here that 287 million kilograms was bought. At a price of 10, 230 million kilograms was bought. It says calculate the PED of demand when price increases from 7 to 10. All right, well, we're going to go here. We're going to use this formula. Q2 is 230. Q1 is minus 287 divided by Q1, which is 287. Now, Q1 is 287, but you take it away. Okay? And then we've got P2 is 10 minus P1, which is 7, all over 7. Now, that looks like a horrible form, and it is, right? So what we're going to do here is we're going to go 230 minus 287. That equals minus 57. So up here, right, so I'm doing this bit here. So minus 57 over 287, all divided by 3 over 7. How horrible is that? Honestly, that's ridiculous, right? So we're going to go down here, and I'm going to go, right, minus 57 over 287 multiplied by, we're dividing by this, so we have to flip it, which is 7 over 3. And how do you multiply fractions? Top by top and bottom by bottom. So what we have up here now is minus 57 times 7 equals minus 399 minus 399 divided by 287 by 3. And that's 861. Okay? Sorry, you didn't see that there. That's 861. I'll just put that there so you can see. You can't. Okay, 861. Apologies. 861. There we go. Now, so now what I'm going to do is I'm going to get the calculator out and hopefully move it to somewhere where you can see it, which is 399 divided by 861, and that equals minus 0.43. 3. So your answer equals minus 0.46. What that means is that if price changes by 1%, quantity demanded will change by 0.46%. Okay, don't worry if you get unusual numbers, right? But and the reason that it's minus is because the law of demand. As the price rises, quantity demanded falls. And it's percentage change in quantity demanded over the percentage change in price. All right. So if as price rises, so that'll be a minus divided by a plus, because quantity demand will fall, which is a negative, and price will rise. So that's a positive. So a minus divided by a plus is a negative. All right. And if price, let me get this right, falls and quantity demanded therefore rises, it'll be a plus divided by a minus. All right. So that's just that there. Now, excellent. Move on to the next one. Adjusting the camera. Okay, so explain why for a linear demand curve, the PED is not represented by the slope of the demand curve. And this is the reason why. PED is percentage change in quantity demanded by the percentage change in price. Whereas the slope is not a percentage change. Okay, it is not. All right, so what's happening here is the slope of linear demand curve is the same along the curve. However, the rates of change, which is what the percentage change is it is a rate of change, and quantity, rate of change of price and quantity are not constant. So think about this. This means that as price increases, the percentage change in price diminishes, while the percentage change in quantity demanded increases. Now that doesn't happen with slope. The slope is like -2 all the way along or whatever, right? That's the number before the P. We know that. Okay, that's going to be, so that would be QD equals, A minus 2P. That would be a slope of -2. All right, so but that's not the same quantity with PED, because PED is measuring rates of change. It's percentage change in quantity demand divided by percentage change in price. Therefore, the slope, which is constant, cannot represent this formula, which is percentage change in quantity demanded over percentage change in price. Okay. Now, have I done all of this? No, I haven't. Right, so on to the next one. Now, again, don't worry too much about this. I'll explain how to get the figures, okay? So this is the demand curve here. D equals A or average revenue. All right, so calculate the price elasticity of demand when price decreases from $18 per unit to $12 per unit. Right, well, again, how do we do this? How do we find the quantity demanded at a given price? Well, we go out from the price to the quantity demanded and go to the demand curve, and go down, and that will tell us the quantity demanded. So at a price of 18, you touch the demand curve, you go down, and 20 is bought. So at a price of 18, 20 is bought. At a price of 12, we go out, we touch the demand curve, which is here. Yes, it's crossing what's called the marginal cost curve. And we go down and we get 26. So again, okay, so what's that? That's a 33% reduction in price. And what, that's a 30% increase in quantity demanded. So, you know, you can work these out quick enough, but let's not do that. Let's take our time and use the formula, okay? So Q2 is 26, so we've got PED equals Q2 minus Q1. So it's 26 minus 20 over Q1, which is 20, all divided by P2, which is 12, minus P1, and I realize I haven't explained the negative figure, I think, yet, all over P1, which is 18. Okay, I'll explain that now. Hopefully I'll remember. So what we have is 6 over 20, all divided, because 26 divided by 20, all over minus 6 over 18. Now let's cancel some stuff down, right? So that's 3, and that's 10, and this is minus 2, and that's 6. I hope I am right. Yeah, which actually, sorry, that's really stupid. That's minus 1, and that's 3. So now what we've got is 3 over 10, all divided by minus 1 over 3. So that equals 3 over 10 multiplied by 3 over minus 1. And that's 9 over minus 10, which equals minus 0.9. Okay, now what this means here is that if price rises by 1%, quantity demanded will fall. That's what the minus figure, and I did explain it, do apologize. Quantity demanded will fall by 0.9%. That makes it inelastic because quantity demanded is not responding by the same percent that price is changing. Quantity demanded is changing by a lower percentage than price is changing, because don't forget, this formula gives you a 1% change in price. What would be the percentage change in quantity demanded following a 1% change in price? This is saying that if price changes by 1%, quantity demanded will change by 0.9% or less than 1. Okay, that's what that's saying. Now again, some unusual kind of demand curves and stuff like that, so don't worry too much about this. But just realize that this here, now forgive me, is the demand curve. If you can't see, the demand curve has a kink in it, and it's to do with oligopoly. All right, so now I'm going to need some more paper here. So it says, calculate the PED or price elasticity of demand if price increases to 12. So it was at 10 because it says up here it's 10 per unit. So P1 is 10. So at a price of 10, you go out and you go down, and that's 21, 22. So I'm going to write 22 there. So therefore Q1 is 22. And at a price of 12, we go up here, touch the demand curve and go down, and that is 9, and I'm correct to believe that. Okay, so what do we have here? And I'll write out the PED formula quickly. What we have here is PED equals Q2 minus Q1 over Q1 divided by P2 minus P1 over P1. So why is 10 P1? Well, 10 is P1 because it is the first price. Price was $10 per unit. Okay, why is P2 12? Because it was the second price. It had changed. So what we're saying here is, and Q1 is the quantity at the first price, and the first price was 10, so we go out to the demand curve, touch it, go down, that's 22. So what we've got is Q2 minus Q1, which equals 22 minus, and I believe sorry, I always make this mistake. That's why it's so important to write down 9 minus 22, because Q1 is 22 and 9 is Q2. So it's Q2 minus Q1 over Q1, which is 22, divided by P2 is 12 minus P1, which is 12 minus 10 all over 10. Now, let's get out the calculator here again. Okay. And we have 9 minus 22 equals minus 13. Minus 13 over 22 divided by 2 over 10. All right. Now, this one won't cancel down. So we've got minus 13 over 22, but this one will, which is 1 and 5. Okay. Multiplied by what? 5 over 1. Okay. So minus 13 by 5 equals minus 65. Okay. Divided by 22 by 1 is 22. So I'm going to go over here just to make sure you can see it, and you can. I'll push it up a little bit. Divided by 22 equals, and we get minus 2.95 equals minus 2.95. Now, yes, it's a minus. That just means that it obeys the law of demand. Because it's a minus. As price goes up, quantity demanded goes down. But the 2.95 is bigger than 1. So when price changes by 1%, quantity demanded changes by 2.95 in the opposite direction. That means if price goes up by 1%, quantity demanded goes down by 2.95. If price goes down by 1%, quantity demanded goes up by 2.95%. Okay, and we should see that because this portion of the curve is elastic. It's pretty flat. It's flatter than a 45-degree line. So answer equals minus 2.95. Okay, now for the next question here, it's talking about moving from 10, so I'll just make sure you can see everything, moving from 10 to a price of 4. Now this is a steep curve showing that it's inelastic, so we really should get a number in absolute terms less than 1, between 0 and 1. Okay, so P1 is 10, P2 is 4, right? So we know what the quantity demanded is at a price of 10, it's 22. So at a price of 4, you go 8, you go down, and I believe that's 28. Okay, so what we've got here is it's PED equals Q2 minus Q1 over Q1, all divided by P2 minus P1 all over P1. And what that equals, Q2 is 28, that is true, just checking, so it's 28 minus 22, just making sure I'm right, 28 minus 22 all over 22. Divided by P2 is 4 minus 10, 4 minus 10, all over 10. Okay, so what we have now is 28 minus 22 is 6, okay, over 22, which equals 3 over 11. And all of that's divided by minus 6 over 10, which is minus 3 over 5. So what we have is 3 over 11 multiplied by, flip this over, 5 over minus 3. This cancels here, so we get minus 1, we get 1, which equals 1 over 11 multiplied by 5 over minus 1, which equals 5 over minus 11. And what I'll do here now is I'll just put this so you can see it in spite of the shine on it, and I will go 5 divided by 11 equals minus 0.45. Okay, now your answer should be written in the absolute form, which is 0.45. So I should make that a plus, and ANS answer equals 0.45. Now what that means is that this demand curve here is inelastic. The quantity demanded will change by a smaller proportion than the percentage change in price. If price rises by 1%, quantity demanded will fall by 0.45%. Okay, that's what that means, right? Now, are we here? We're all good. Yeah, I can get rid of that. Lovely. Okay, now on to question 6. Now, in the country of Zestria, the monthly demand for good X is given by the function that, where QD is price per quantity per month and P is price per unit in dollars. From the equation, identify the slope. Could not be easier, okay? From the equation here, we have 420 minus 30p. Slope equals minus 30. What that means is that if price rises by $1, the quantity demanded will fall by 30 units. That's what that means. We're done. That's that question over. Calculate the price at which the monthly quantity demanded would be 210 units. We have QD equals 420 minus 30p. Okay, so instead of QD, we're going to write 210 equals 420 minus 30p. As I said, I like to get my p's over to the left-hand side, so we've got 30p equals 420, excuse me, minus 210. 30p equals 210, okay, and I believe that's 7. Okay, 210 divided by 30 equals 7, yeah. So P, well sorry, I just divide both by 30 just to show you. Cancel, cancel. P equals 7. Okay, $7. Now, calculate the price at which the monthly quantity demanded will be 60 units. Okay, we go QD equals 420 minus 30p. QD equals, what do we need? 60. So 60 equals 420 minus 30p, bring the minus 30p, get 30p equals 420 minus 60, 30p equals, what's that now? Is that 360? Yeah, 360. Divide both sides by 30. Just again, just making sure we have 420 minus 60, 360 divided by 30, which I believe is 12, and it is. Cancel, cancel. Price equals $12. And let me just fix that up here as well, $12. Okay, now, no problem there. All right, absolutely no problem. So the next thing it says is label the axes on the demand curve in the grid above. All right, so I mean, you just got price. I wrote price of good X in dollars per unit, quantity of good X demanded per month, and I wrote demand curve up there. That's 6D done. Construct the demand curve for good X. Well, the thing is, we don't really have to do anything, right? We already know that 420 is the point where it touches the quantity axis, so 20, 40, 60, 81. So there's 420 there, okay? But also, we've got 2 points on this. We've got a price of 7 and 210 units. So let's go up to 7, which is here, and then 210, which is not a great one to use. So 12 and 60 would be a better one, because 210 I think is like there, and it's not otherwise 20, 40, 60, 81, yeah. And then we've got 12, which is here, and we have at a price of 12, 60 units, 620, 60. And if we went 420 divided by 30, we get 14, and we should expect it to hit there, okay? So let's put our ruler out and let's see what we get when we join these dots. Remembering, and I'm actually going to draw this in pencil in case I make any mistakes, which I hope I don't, and I don't think I have, but... And there we go. And there's our demand curve, okay? So that's our demand curve there. And look, every dot is on that line, so we've drawn it correctly, all right? Excellent stuff. Now, on to 6F. Outline why the position of the demand curve above will change if the demand function changes to, now ignore the red for the second, QD equals 500 minus 30p. Well, the question is, what has changed? And the answer is the intercept, the number on its own, the A value, where it touches this. So instead of touching it here, it's now touching out there. Right? That is equivalent to an outward shift. If this number gets bigger, the whole curve shifts outwards. If this number gets smaller, the whole curve shifts inwards. There's no change in slope because it was minus 30p. So the number before p is the slope. It was minus 30, it is minus 30. All that's happened is an outward shift because the A value has gotten bigger. Okay? So the demand curve will shift to the right by 80 units at each price, because the quantity demanded has increased by 80 units at each price. Well, if I put in 1 here and I put in 1 here, this is going to be 80 units bigger. If I put in 2 here for P and put in 2 here for P, this is going to be 80 units bigger. At every single price, 80 units more is being demanded. That's what that's saying. Now, excellent. Okay, just again, move this up so we can see, and we're all good. Okay, outline how the steepness of the demand curve in 2 or above will change if it changes from 420 to minus 40p. And it was originally, QD was originally minus 30p. Well, what we've said here now is essentially quantity demanded has become more sensitive to price changes. What that means is the demand for the good, the PED, has become more elastic. If price changes by 1, now quantity changes by 40 instead of 30, as it did originally. So that's something to keep in mind. So you have to understand that the slope has changed and it's become more elastic, and an elastic demand curve is flatter. So the demand curve will become less steep. This means that the demand curve will become shallower or flatter. Now forgive me, skip all this stuff here. I just want to read this bit down the bottom. This is because for any change in price, the change in quantity demanded will be greater, and hence the curve will be flatter. It is more elastic. That's what's happening there. The curve has become more elastic. Now, on to 6H. The following provides data on price and quantity demanded per month of 3 goods in Zestria. January for good A, right? Calculate the price elasticity of demand for good A when its price falls between January and February. So here's good A. The price in January was 8, now it's 6, so that's P1, that's P2. In January, 160 units were purchased. Now in February, 220 units were purchased. So we've already got, that's where I'm getting all of these from, is from this table. So now what we're going to do is we're going to go PED equals Q2, which is 220, minus Q1, which is 160, over Q1, which is 160, divided by P2, which is 6, minus P1, which is 8, all over 8. So what we have here now is 60 divided by 160, all over minus 2 divided by 8. Now, that equals, if I divide this by, let's say, 20, okay, that equals 3 over, so that's 3, and divide this by 20, what's that, 8? Yeah, okay, over 8. Again, just out of fear, because I don't do something stupid on a video, 160 divided by 20 equals 8, okay, divided by minus 1 over 4, divide both of these by 2. That equals 3 over 8 multiplied by 4 over minus 1, and if you want, actually, you can, that's 1 and that's 2, so that equals 3 over minus 2, which equals minus 1.5, so the answer equals 1.5. That means that that good is elastic. The reason that we know that is because its PED is greater than 1. Now, what does PED mean? PED measures the percentage change in quantity demanded following a 1% change in price. Elastic means that the responsiveness of quantity demanded in terms of a percentage is greater than the percentage change in price. So if price changes by 1%, which this formula always assumes, well, it doesn't assume, it works it out, what would be the effect, the percentage change in quantity demanded of a 1% change in price. So if price changes by 1%, then quantity demanded will change by 1.5. That is more than proportional to the change in price, and as such, the good is elastic. Okay. HI, right, okay, so here we go. Now, good J and K are both produced in Zestria. The price elasticity of demand for good J, a primary commodity, is minus 0.2. That means it obeys the law of demand. Sorry about the bell. That means it obeys the law of demand. And it obeys the law of demand, and it is inelastic because its PED is less than 1. The price elasticity of demand for good K, a manufactured good, is minus 2.3. It's minus, so it obeys the law of demand, and it's an elastic good because this number is bigger than 1, meaning that a percentage change in quantity demanded is greater than the percentage change in price. Explain 2 reasons why the demand for products such as good K tends to be relatively price elastic. Manufactured goods are more elastic compared to the demand for primary goods, such as good J. Well, primary products have fewer substitutes is the first reason. Okay, now it says 2, I'm going to give you 3. Primary products have fewer substitutes. There tends to be fewer substitutes for the primary product. Hence, demand would be relatively price inelastic. With the fewer substitutes, the less choice the consumers have, so therefore they are more likely to accept a price rise and not reduce their demand by as much as the price has increased in percentage terms. Manufactured products tend to have elastic demand as they are likely to have more substitutes owing to greater opportunity for product differentiation, greater opportunity to switch as well from consumers. Now, the proportion of consumers' income. Spending on manufactured goods tends to represent a considerable part of consumers' income. The higher the proportion of your income you spend on the good, the more elastic it is, the more responsive quantity demanded is to price change, the more consumers reduce their consumption of the good following an increase in their price. As a result, demand will be relatively price elastic. However, spending on primary commodities is likely to take a smaller proportion of consumers' income. As a result, demand would tend to be relatively inelastic. Okay, and for the last one, necessity versus luxury, primary commodities are often necessities, okay, and hence demand would be inelastic or more inelastic or relatively inelastic compared to manufactured goods. And again, why? Manufactured goods are more likely to be luxuries, and as such, demand would be more likely elastic. Now, I have not done this one. Okay, so question here now. Okay, question 7. There are concerns about rising food prices and their impact on households. Economists have forecast that rising food prices have a negative effect on the demand for goods in other product groups. Now, outline one reason why the price elasticity of demand figures are negative. Now, this is what we've always said, right? And remember this. This is due to the law of demand. As the price of a good increases, the quantity demanded decreases and vice versa. This means that there is a negative relationship. As price goes up, quantity demanded goes down, and that is a minus divided by a plus. As price goes down, quantity demanded goes up, that's a plus divided by a minus. In either case, the answer is a minus. Okay? This means that there is a negative relationship. That's what a negative relationship means. As one variable goes up, the other variable goes down between price and quantity demanded, because if price increases, the willingness and ability to purchase the good decreases. Okay? E-C or E-A-S-E-S. Excellent. Okay, have I done all of that? And I believe I have. Now, using the price elasticity of demand data in the table, okay, which I'll show you in a second, calculate the percentage change in quantity demanded. I just want to make sure. Yeah, perfect. Calculate the percentage change in quantity demanded for clothing and footwear if the price of the clothing rises by 6%. Okay, so what we're saying here is, let's look at this. We're talking about clothing. The PED is minus 0.71. That's all we need to know for the moment. Okay? So the PED is minus 0.71. We're asked to calculate the percentage change in quantity demanded if the price of clothing rises by 6%. So now all we're going to do is plug and chug, okay? Put our numbers into this formula. Percentage change in quantity demanded equals, or over 6%. And this is over 1. So what we have here is a single fraction equal to a single fraction. So now we're going to cross multiply. So what that means is it's minus 0.71 multiplied by 6 equals 1 times percentage change in quantity demanded. Right? So now what I do is I take out my trusty iPhone, put it where you can actually see the screen, and I go 0.71 multiplied by 6 equals, and we get 4.26. So we get minus 4.26 equals percentage, again forgive me, equals percentage change in quantity demanded. Okay, so what we're saying here is that if price rose by 6%, quantity demanded would fall by 4.26%. That's what we're saying there. We're almost done, guys. Okay, now the next one here asks the question, using the price elasticity of demand in the table, calculate the percentage change in the price of house furnishings that can lead to a 2% fall in quantity demanded. Right, well, we have to come back to the table, and we're going house furnishings. The PED for that is minus 0.77, okay? That's where I got it from, but we've written it here. And the percentage change in quantity demanded is 2. So we go minus 0.77 equals minus 2 over percentage change in price. That's over 1. Now, look, I'll set it up the long way. We cross multiply, all right? So what we've got here is minus 0.77 times percentage change in price equals 1 times minus 2. So that means minus 0.77 times percentage change in price equals minus 2. So what we do then is we divide both sides by the number before the letter we're trying to find. We're trying to find this variable rather than just a single letter. These cancel, and what we're left is percentage change in price equals, and I'm going to say it's minus 2 divided by minus 77 or 0.77. But I'm going to go 2 divided by 0.77, and that equals 2.597, which is 2.60. Equals 2.597 equals 2.60. Okay, and that is the percentage change in price that would have to occur. Price would have to rise by 2.6% in order to cause quantity demanded to fall by 2%. Now, using the price elasticity of demand data in the table, describe what might happen to the revenues of food and beverages firms as the price of food and beverages increases. Well, let's have a look. The food and beverages firms, where are these? Minus 4.9. So it obeys the law of demand. So if price increases, all right, people are going to buy less, but they're going to buy proportionately less compared to the increase in price. So their revenue will increase, because if price goes up by 1%, quantity demanded falls by less than that, which is it's less than half of that. So they're at a point where they really should increase their price in order to increase their revenue. As the price of food and beverages increases, the revenue earned by food and beverage firms increases. Why? Because price is rising at a faster rate than quantity demanded is falling. Because demand is price inelastic, so the increase in price leads to a proportionately smaller decrease in quantity demanded. Price is rising, therefore they're at a faster rate than the quantity that is falling. So therefore, their revenue is rising, because every time price goes up by 1%, quantity demanded only falls by 0.49%. So their revenue is falling as they are increasing price at that point in the demand curve. Okay guys, I really hope that was helpful, and I'll see you in the next video.